We're back. Unit 3.2. 3.1, we're in the same spot we were before. It's in Unit 3. The class is Unit 3. And we're continuing where we left off. So these are all the variables that we are going to be using. And in Unit 3.2, what we're going to be doing is variable assignment. So we declared these variables, but it didn't have values yet. An assignment simply means give these variables a value. So I'm going to start off with the first value, and the variable name is called value, and it's going to be 10. This is an assignment. Okay. So let me just get this clear here. This is an assignment. It is not equal. Okay, let's just get that one clear. It is not equal. So assignment mean, I don't say assignments, this is an assignment. All it means is take this guy on the right side and assign it, that's what this means, assign it to the guy on the left. So this is 10. At this point you should be wondering, how does that look in binary? Gotta convert it to binary. That's what happens in the computer. But this is 10, and this 10 is stored in value, who is 4 bytes right now. And if you're wondering, well, 32 bits, that's a lot of zeros in front. You're correct. However, this 10 being assigned to value happens in random access memory. Memory is destructive. What do I mean by that? Is that if I go ahead and I make another assignment underneath, this assignment gets erased because the second assignment, so in essence this used to be a 10 just like a little millisecond ago, and then we come along and we changed it. All right, so value can change on assignment. If I assign a new value to it, the 10 is erased, 20 is now in the spot. That's what I mean by memory is destructive, and it is true for all variables. Okay, so I'm not going to go ahead and just change the value right now, but I want you to keep that in mind is every time you use an assignment, whatever was there before gets erased. Now I gotta go and give a cost, and I'm gonna give the $4.38 that we talked about. And it's a decimal value. And I'm gonna say is full. It's true, that means it's actually full. And I'm gonna make the character, I'm gonna make that equal to C. Now one thing I wanted to pay attention here is how to make the assignment. Because it's a different variable, obviously the assignment's gonna look different. For an integer, it's an integer, like 10. If it's a double, it's a decimal, like 4.38, and it's a boolean, it's true. Now this is very important. I cannot make the wrong assignment. Okay? Now you want to make sure that the type is the same on the left and on the right. So for example, this is an integer, so this better be an integer. This is a decimal number, this better be a decimal number, and so on. So that's my primitives. Okay, so let me just put a little note here. This is where we are my primitives. Primitive assignment. Okay, so now I'm going to go ahead and do some object assignment. A little different. So object assignment. So for the primitives, you just get the right type. It's nice and simple, and you assign it, and it's done. For the objects, a little bit more. Okay, so value object, I could assign it the value 10. Okay, I could do that. However, that actually does not happen. Instead, this does. To create an object, you need the keyword new. That's how you create an instance of the class. Just like in our main method when we say new, welcome, new something, we're creating an instance. Here we are creating an instance of an integer object. This statement is exactly this statement. These classes are what we call immutable, means they cannot be changed. So every time you make an assignment like this is what actually happens. So you will say, well, wait a minute. If this is the same as this, why are we bother writing this long thing? Well, I'm writing it to let you know that is what actually happens because there's something called auto boxing. Auto boxing simply means when you make an assignment with an integer object as if it were an integer primitive, the system does the object work for you. So I'm going to go ahead and put this next to this up here and put a comment and say these are the same. So you either do it this way or you do it this way. However, doesn't matter if you do it this way or this way, only this way works. Okay, so in this case here, even though we're writing it in a shorthand way as if we're doing this, okay, the system will do this for us, so we're safe. So let's do the same thing with cost. Cost, I could say it's for, not cost, we want a cost object. I could say it's for 38. Same thing is true. So guess what that's the same as? That's the same as cost object equal to new double 4.38. Okay, now put this down here so you could take a look and see how it looks in code. See the keyword new? The keyword new turns red, which means it's a special word. It's only used to instantiate, that's the word we use, an object or create a new double object. And the same is true for all of them. Okay, so if we want to make the is full object, we could say it's true. Or we can say the is full object equals to a new Boolean who is true. So all these different variables have their own way for assignment, and we need to pay attention to how we assign things. We're going to be seeing this new keyword a lot, so get used to it. And the character object, obviously, you could do it and say, let it be a C. Okay? Or we can say the character object equals to new character. It's going to be a C. Now, because we have these two ways of making this, it doesn't mean you have to make them two ways. You can use the easy way on the left here, but don't confuse these with these. Okay? This never really happens. Just keep in mind that this is what actually happening. The computer gives us the chance to write it in shorthand while it takes care of the long typing for us behind the scenes. The other one is the name. Like I said, string, special one. So let me drop down a little bit and let's say the name in quotes. Put my name. We could do this. This is called a string literal. It simply means it's literally what you're seeing. A string is basically any character on the keyboard, space included. I can put a space here, I could put an exclamation, I could put a caret, I could put an @ sign. Any character, a set of them or a sequence of them, put in two quotes gives us a string. And if you remember, the ASCII for 32 was, space was 32. So even that has a number. Now all of this can make up a string. Okay, I'm going to make sure the string is actually a name because I called it the variable name. That's another thing too. When you're using variables, you want to name them something that makes sense. Okay? You want to name them something that corresponds to whatever you're doing. So if I'm writing an app that has to do with a name, I'm going to call it name. Now this string literal is not the only way to make a string. We could also say name equals to new string and put my name in there. Okay. So the literal itself could be used to make the string. Normally we would make strings this way. Just like I say, it's better to write it the shorthand way. We will normally do it this way. But you got to keep in mind that this is also another way to do it. Okay. Now there are other ways to make strings, but as it stands right now, these are the only two that we are actually gonna use. Well, more so the first one than the second, but we have to keep in mind that this actually happens. Like on the right side of the wrapper classes, this new double, new boolean, new string actually is what takes place. So now this string literal here is the best way for us to work with strings. And strings have a lot of pieces to them in terms of what we need to do and how we're going to work with them. So like I keep saying that this is very important. So let's just make sure we focus on this when we're writing any app. You're going to see it a lot for the whole year. So keep that in mind. Again, these are all just assignments. Make sure your type's matching. So let's see. Suppose I try to put, let's put a 10 there. Okay. Or let's put a string there. Okay. You may or may not get an error. Okay. I'm doing something that is not right through here. Okay. You might get a mistake. You might not get a mistake. So if I put my cursor over the mistake, it's going to try to tell me that something is wrong here. Mismatch, mismatch. Cannot convert from Boolean to character. Mismatch. So don't want to do that. Don't want mixed types. Okay. So we're going to make sure the type on the left matches the type on the right on assignment. Okay. This is not an equal. Remember, this is an assignment. Put this in memory spot value who holds 4 bytes and put number 10 there for now. Now 3.2 was assignment, and I just said that you want to make sure you do the assignments right. But one thing that's important is you should be able to sometimes go from one type to a next. Okay, how do I go from this particular type to the other type? Because I want to do it in my app. It's important. That also exists, and that will be covered in 3.3. So for now, the assignment, make sure that you're assigning the right type to the right variable, and you should be fine. That brings us to the end of 3.2.